Welcome to the video tutorials of mechanisms by mekanizmalar. Without a doubt, the invention of the wheel is one of the most important inventions in human history. Why was it so important? When you do a Google search on the topic, you will find many explanations which explain the benefits of the wheel, but they do not mention the core reason of the importance of the wheel. With this video, I will try to include my 2 cents on the subject. First, let's ask ourselves what the power requirement to move a load from point A to B on a flat surface is. You can assume any valid value for the load or any other input you need to calculate this power. It is paradoxical that the power we consume to carry the load is zero. That does not make sense. It is zero because the definition of the power in the engineering field is vector product of force and velocity. As you can see in the slide shown, the force vector and velocity vector have 90-degree angle between them. This makes the result of this vector product zero. You may say, okay, I got it, but then why do I get tired when I carry a heavy load? The answer is, you will get tired even if you don't walk. A heavy load will put a lot of pressure on your skeleton and your muscles. The solution to this problem is to carry the load indirectly. We all drag heavy loads rather than to carry them. This behavior allows us to put the weight on the ground and we overcome the friction force while we're dragging. This friction force is comparably smaller than the weight of the actual load. To reduce the friction force even more, we have to create some mechanism to drag the load. One solution used by many American Indians is the travois shown in this photo. Now, let's investigate the problems of using a travois. In this design, the friction between the load and the ground is reduced by having X-shaped poles on the horseback. This reduces the friction substantially, but it does put some load on the horse's shoulders. Let's do a leverage calculation of this mechanism. 100 kg load put in the middle of the pole, where the midpoint is the point between the poles attached on the horseback and touch the ground. Assuming that the pole length from shoulder to ground is 3 meters, this arrangement will put a 50 kg load on the shoulders of the horse. For a 300 kg load it will jump to 150 for the horse. Apparently, this is not a very good arrangement for the horse. Also, the pole ends that are touching the ground are subject to heavy wear and tear. Ordinary wheelbarrows are similar in operation to the travois with a slight improvement. The addition of the wheel at the end reduces the friction to a minimum. This is due to the fact that the rolling resistance is much smaller than dragging friction. However, the operator is burdened with carry a fraction of the load. We can do much better than that. A much better solution comes from China, where fulcrum, load weight, and reaction force all lined up on a vertical line passing through the wheel touching the ground. This arrangement removes any load on the person pushing it and enable him to carry much heavier loads. They even went further to use sails to help push whenever the wind was coming from the desired direction. The same idea has been used by Americans to carry large logs with ease by using big wheels where the load was hanging from the axle of the wheels. Here is another view of the big wheel. In short, to carry loads by wheel or slides, the load should be on the axle for 2-wheeled carriages, or between axles for 4-wheeled carriages. Same is true for slides. This slide shows that 4 horses can pull enormous weight, while 1 horse will not be able to carry even 1 log on its back. Here is a picture of an Egyptian chariot. Notice that the pharaoh and rider are standing on the axle, which removes the load from the horse. Also, the large 6-spoked wheels substantially reduce rolling friction with the ground. The horses could run full speed with ease. The chariot was considered the battle tank of its time. It allowed Egyptians to expand their empire. However, there is a small catch. While the wheeled carriages had big advantages on the flat surface, they have one major disadvantage on the hilly roads. When a person carrying a load uphill, there is a component of its weight and the load dragging him backwards. Multiplication of this vector with velocity will not be zero this time. Hence, the power requirement to carry the load and person himself will be proportional with this apposing vector. Higher the climbing angle, the higher will be the power requirement. The same thing happens to bicycles, cars and trucks. While they are on an uphill road, they not only carry the load, they also carry the additional weight of the equipment, whether it's a car or a truck. We have to build flat highways whenever it is possible, by building tunnels or bridges. This will reduce fuel consumption of cars and trucks substantially by shortening the distance and eliminating opposing force component if trucks were climbing. If you are using single two-wheeled cart, make sure that the center of gravity passes through the axle of the cart or a little bit toward donkey's side. As you can see, opposite shift of the load will put poor donkey in very awkward position. In short, the wheel takes the heavy load from our shoulder and put all the weight on the ground. With overcoming slight rolling resistance, it enables us to easily carry very heavy loads. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.